I'm going to go ahead and get started. Thank you everybody for coming. I'm Jeff Klukas. I am giving this talk that is called Building an Analytics Platform. Hopefully you read the longer description of the talk. You know that I'm going to talk about data warehouses. I'll define what that is. Specifically, I'll be talking about Redshift as the data warehouse that Simple uses. There's the URL on that. This is based on a blog post at that URL that I wrote last November. And in general, this talk is about experience that Simple had building kind of the first version of our data architecture and how we perform analytics. A lot of this has changed in terms of what we actually do today, but it's kind of a nice snapshot of how did we decide to build what we built and what is the point of it. So what even is analytics? That's a good question. What is an analytics platform? If you have a preconceived notion of what that is and it differs from what I'm presenting on today, I am sorry for that. There are a lot of terms in technology in areas that are quickly changing that who even knows what they mean? In terms of what is my understanding of what analytics is, it's about a business understanding what's going on in the business itself and understanding its product. How are users using that product? How do you gain insight into that so that people can make reasonable decisions based on having some idea of what's actually going on in the real world? So an analytics platform is about gathering that information about what's going on with the business, what's going on with the product, and putting it in a place where people can actually analyze it and make decisions based on it. At the bottom of the slide, I have this blurb about meeting Simple. I think it's really important, because analytics is so much about allowing the business to improve. It's about understanding what is the business doing. You kind of have to have some context for what even is this this business that we're building a platform for. So I want to give you some of that context. I'm going to spend kind of the first 5 minutes of this talk introducing you to Simple, both as a company and as a product. As I was rehearsing this, I realized that those 5 minutes kind of end up sounding like an advertisement for Simple. And I'm kind of okay with that because I think it's a cool product. I definitely encourage you to go to simple.com and sign up for an account. I'll tell you more about what Simple is in a little bit. First, I want to tell you about the company. So this is Simple's headquarters that we just moved into this past summer. It is in Portland, Oregon. I do not live in Portland, Oregon. I live in the Columbus area. And I work remotely. When I joined Simple, it was about 150 people total, and for our engineering workforce, about a third of us are remote. So the team I work on particularly, we've kind of fluctuated. Some people have moved to Portland, some people have moved out of Portland in the time that I've been there, and it's been about half remote. I work out of the guest bedroom in my house, and I get to eat lunch with my 2 kids and my wife every day, and I have found my happiness. It is a wonderful situation. So yeah, I love working remotely, and I love being a part of Simple. So what I'm going to talk about today, there was a team of about 4 data engineers when I started. We're like, okay, we're supposed to build a data platform, and we kind of learned from the ground up how to do that. We're going to kind of follow that. It took us about 6 months to put together our first draft of it, and then it took us another 6 months to kind of build out all the data sources that we actually wanted to get into that platform. I'm going to talk more about Simple's product in just a moment. If you don't already know about Simple's product, you may know Simple for another reason, and I'm about to troll the Columbus residents in the audience. Are there any soccer fans in here? No, okay, well this troll is not going to work very well. Simple builds a product. They're also a sponsor of the Portland Timbers. So if you're not familiar with soccer, Portland, the Timbers played the Columbus Crew in the championship last year, and it did not turn out very well for Columbus. And there are allegations of bad calls that the refs made and all that. So it's a hot topic. I considered wearing my Timbers jersey today, and I figured that's probably a bad idea. So just a quick note, Simple is hiring for a lot of roles. If you're interested, talk to me. A lot of these allow remote work too. So what is Simple's product? Simple aims to make banking beautiful and to increase people's confidence with their money. So I'm going to talk about just 2 quick features of our application. So when you sign up for Simple, you get a bank account, you get a checking account, and you get a debit card to interact with that checking account. You also get mobile applications and a web application. One of the big features is called Goals. It's a budgeting feature. It allows you a way to define, I want to save up for this thing. This is how much I want to save for it. This is how long I expect to take to get there. And it helps you, manage where your money is going. Another big feature is called Safe to Spend. So when you open up the Simple app, there's this big number that appears to you. For a normal bank, that would be your bank account balance. How much money do you have in your account? Simple instead shows you Safe to Spend, which that is your bank account balance, but we subtract out the goals that you have set. So you kind of squirrel away money in goals, and we essentially hide it from you so that you know what can you actually spend without derailing your goals that you've set for yourself. We also put into there, you can schedule bill payments through Simple, and we add that into your Safe to Spend as well, so that the bill that's going to go out in 2 days, you aren't spending money that is then not going to be in your account. The whole goal of this is you should never overdraft your account because you actually know what's in there. This is how we give people confidence with their money. So given just those 2 quick features of Simple, this slide is where I really give you the understanding of what are we trying to accomplish with analytics at Simple. Is let's go through what happens, what's a typical interaction that a user has with the app. So you're in a coffee shop, you go in, you buy some coffee, you give them your Simple card, they swipe your Simple card. What happens after that is they give you your card back, your phone, you get a push notification on there. It tells you just spent $3 at Starbucks. Hopefully this is not news to you because you just swiped your card. But you can tap on that notification that you just got. It'll open up the app, deep link you into that transaction that just happened. And there are ways you can interact with it. So you can add a memo to help you, you can put hashtags in there so that you can go look through your budget later and see what you were actually doing. And you can choose to spend from a goal. So if you've set up a coffee goal, you say you've got $100 in there for coffee for the month, you can say, okay, this is coffee, I want to spend it from that goal. And it'll come out of that goal rather than your Safe to Spend. So this is kind of how users are interacting with the app. The question is, though, what just happened there? From the user's perspective, they opened up the app and they interacted with it. From the back-end perspective, or what's actually happening in the application, there's a whole bunch of stuff that just happened. So when you swipe your card, it talks to Visa. Visa then talks to some computers at our partner bank that actually holds the checking account. That bank, their systems come and talk to Simple's infrastructure to say, hey, there's this transaction, do you want to authorize this? We say, yes, we want to authorize it. There's a row that gets inserted into a database and a microservice in Simple's infrastructure, and then some other stuff happens. But there's now information in the database about that interaction that just happened. That's interesting to know about, and we'd like to have access to that to do some analysis on it. Another thing that happens is that push notification that you got, that was because when that transaction happened in our back end, it put a message on a message queue that eventually got to some third party that's then sending a push notification back to your phone. But that message queue is something that's in Simple's infrastructure, and it might be nice to get access to that message and be able to do analysis on the messages that are coming through there. When you open up the app, every time you go to a page, there are events. That app is instrumented. It's sending events back to our infrastructure so we know what users are doing in the app. And then that spending from the goal, again, that's hitting a certain page in the app. We get a client event. There's also database activity, where you're changing activity associated with the goal. We're recording records about that. So this is a bunch of stuff happening in the infrastructure. It's scattered all over the place. You might be able to do some analysis on that. You might be able to go into that database and ask some questions about transactions. But it's kind of terrifying to do that on a production database. From a security perspective and from a performance perspective, somebody could run a terrible query that then impacts customers. You don't want that. It would be great to offload that to some other system. And same with these other events. It would be nice to get those into a system. We would like to be able to answer questions like, how are people interacting with goals? That push notification that they get, does that increase people's interaction with the app? Does that make them happier users? Are they more likely to use their account in the future because they're seeing that Simple is giving them information about what's going on in their account? So we want to be able to answer those questions, and we want to be able to answer them across all these various bits and pieces in our infrastructure. So we'd love to get that data into one place. And that is the concept of a data warehouse. So I'm going to tell you a little bit about the data warehouse that Simple uses, and I'm going to tell you about what even is a data warehouse. So it's a database. Let's ask Wikipedia what it thinks about data warehouses. Wikipedia says they are central repositories of integrated data from one or more disparate sources. They store current and historical data and are used for creating analytical reports. So let me rephrase that, is that you have a lot of things, you want all the things in one place, you want copies of all the things in one place, and then you want people to get access to those things, and that is a data warehouse. It is a database, but the requirements are a lot different from a production database. A production database, you want to be able to insert a bunch of individual records quickly. You want to be able to query for a particular user really quickly. For a data warehouse, you're typically doing analysis over a lot of users or like a lot of activity. You're looking for trends. You're aggregating data together. And design decisions are usually different. So there are a bunch of products out there that are that build themselves as data warehouses. The one that Simple uses, it's called Amazon Redshift. This is a hosted thing. You just go into the AWS console and you say, I want a Redshift cluster, and you press a button, and then all of this stuff that's in that dotted blue line, that is all Redshift, and there's a ton of stuff that happens. There are all these nodes. It's this distributed thing, but in the end, it just looks like a SQL database. So you can see at the top, the way that you interact with it is there's a single leader node. You connect to that through JDBC or ODBC. These are typical SQL protocols. And Redshift was actually forked from Postgres many years ago. It pretends to be Postgres. So if you can use the pSQL tool at the command line to connect to Redshift and interact with it. You can use basically any SQL client that you want. So it's convenient in that sense. It's just SQL, but there's all this complexity behind the scenes. These compute nodes at the bottom, when you create a table in Redshift, it's not just on one machine. It is distributing your data across all of the nodes that you have. In Simple's case, we have 32 different nodes, and Redshift further divides those into slices. So like your table that you create is actually like 64 different tables with different pieces of data spread across it, which is kind of awesome. Data pipelines is another thing. Like maybe you have a specific idea in your head of what you mean by data pipeline. To me, a data pipeline is just code, like any code you write to get data from one place into another place. So we've got Redshift now. We've booted up a cluster, but we actually have to get data into it. So we have to think about our data pipelines. This is a visual representation of the problem that is at hand. We have source data over there on the left, and we've got a data warehouse over there on the right. And there's nothing connecting them right now. So there's work that we need to do. So this is where we get to, I was talking about, a group of 4 data engineers. We don't really know how to build a platform, a data platform. How do we get this information going around? So what do you do in that situation? You start reading documentation. And so you open up the Redshift docs, and you ask, what even is Redshift? How do we even define a table? And then you figure out how to write a create table statement. So if you have worked with SQL databases before, this should look pretty familiar. And then there are a couple of things that you're like, what on earth is that? And I will explain a little bit about the what on earth is that part. So at the bottom, you'll see a dist key and a sort key. What on earth are those? Those are not normal things that you would see in Postgres or MySQL. These are Redshift-specific concepts. The dist key, so I told you, you create a table, and it's actually creating 64 different tables and distributing data across all of those. The dist key, the distribution key, gives you control over how that data is distributed. So when you say, I want to use the user ID as the distribution key, that means all of the data for a particular user ID is always going to go to the same slice within Redshift. And that's how you handle how data is distributed. Why do you care? Why is that useful? It's because usually you're joining different data together when you're doing an analysis. And in a lot of cases, at least in Simple's case, we often want to join the same user data together from various different sources. So if we distribute all of our tables by user ID, then that means that all of a user's data across all of these different tables ends up on the same slice. And when we do joins between that data, it's all able to happen within that slice, rather than having to go ask for information from some node way over on the other side of the data center. So operationally, these dist keys and sort keys end up being really important. The sort key tells you, this is basically, you don't get indexes in Redshift. Instead, you just get to define this one sort key, and all of your records will be sorted by that. The other thing that is interesting is this encoding. So encode LZO, encode delta. So Redshift is distributed, which makes it different from a normal SQL database. But the second thing that's kind of amazing about it is it's a columnar data store rather than a row-by-row data store. So when you save information in a normal database, it's usually, you take all of these columns, you're saying, the user ID, amount, and when recorded, those will all get stored together as like this one row that got inserted into the database. In Redshift, you instead load a ton of records all at once, and it stores them by column. So you get all of this data that's all of the same type, and it ends up compressing together really well, and you have control over what kind of compression you use. So for timestamps, if you have a whole bunch of timestamps and you're sorting by that timestamp field, there's only going to be a small difference between each timestamp, and it ends up being efficient to just store the difference between each timestamp. So that's a cool detail of Redshift that you get control over, is how is it compressing data. It ends up, you take up less space on disk, and it means you save on I/O when it's pulling data out of disk. So it makes Redshift faster. Okay, so you have now created a table to hold your transactions data. You then ask yourself, how am I going to get data into this table? And you go back to the Redshift docs, and you ask, how are they expecting us to load data in? And they tell you, you should load data in through S3. If you have used AWS, you're probably familiar with S3. But S3 is an object store. You can kind of think of it as a file system. It's not really a file system, but you can take a file and say, I want to store it in S3 in some place, and it'll do it for you. So the interface that Redshift gives you is a SQL statement to copy information from S3. So you run something that looks like this. You say, I want to copy into the transactions table from this particular object that's in S3. And in our case, we do JSON formatted data. You just have this big file that is a bunch of JSON blobs, one per line. And you load in these big batches of data all at once. Redshift is very bad at doing row-by-row operations. Do not try to do individual inserts into Redshift. You will quickly learn the limitations that Redshift has around transactions, and it will be very slow if you try to insert individual records. You have to load things in batches like this. Okay. So we know that we can load data in from S3, batches in S3. Unfortunately, our data is not already in batches in S3. We have these various sources of different kinds. So how are we going to get data into S3? We could, say, let's have the mobile app, batch up a bunch of page views that are happening and then write them to S3. That's a terrible idea for a lot of reasons. One of them is just permissions, like you don't want to give your mobile app the ability to write into your Amazon account. The second thing is that it's just responsibility that the app shouldn't have. It's too much complexity to expect of the app. So you want to provide a nicer interface on top of this. So the way that we did that is we decided it would be really nice if we could use a message queue for this rather than S3, so that our sources of data can write individual messages to this message queue, and then we'll handle the complexity of loading it in. By the way, these like orange square kind of stack things, those are compute things that are happening. In our case, it's a service that we've written. So you now see that we have two services involved. The loader on the bottom exists just to, it sweeps through S3 every once in a while, and it runs those copy statements in order to load stuff into Redshift. So that's a piece of code that we maintain, and that's a burden that we take on to get the data from S3 to Redshift. Now we've introduced another piece of code, another service on top, which is a batcher. And the role of the batcher is to just get information from RabbitMQ, our message queue, batch those up into objects in S3. So this is how we get from things being able to just emit single messages saying, I want to insert this data into Redshift, and getting into a spot where we have these big batches in S3 that we can load efficiently into Redshift. If you're not familiar with message queues, RabbitMQ is a particular message queue technology. Basic idea of message queues is it's usually a publish-subscribe model, so you have some things that are publishing to some exchange of messages, and then you can have a bunch of things all subscribing to those messages. They'll all get pumped back out the other side to the things that are consuming. So the batcher here is consuming from our message queue, and then we have stuff coming into our message queue. And so we have some arrows going into the message queue. We have some arrows coming out of our source data. They aren't quite connecting. It's almost like there's some missing piece in there that Jeff hasn't put on the slide yet. What is that missing piece? Okay. Extra detail I wanted to mention. One of the most successful things about this infrastructure that we built was having a really well-defined interface for this whole message queue thing. So it's not just enough to have a message queue, it's also like what format should the data take. This is exactly the format that we use. Is we expect the things that are going to publish to the message queue, we expect them to publish in this format where it's some JSON. It has one element that is the name of the table you want to put stuff into, and then the second element is a list of column names and the value that you want to associate with that column. So every one of these messages is essentially like one database row. You tell it what table you want and what's the data that you want in the columns. So that's what the messages look like that are coming into our RabbitMQ exchange in the middle there. Okay, what's this missing piece? How do we actually get messages being published onto that message queue? We have an ingestion layer. So this is, again, these are a group of services. This is extra code that we have written. And we have a different piece of code for each event type that we want to, or each data source that we want to pull in. So in the case of client events, that piece of code, that ingester, is actually an HTTP service that's publicly available. So our mobile apps and the web app, when you go to a page, it's behind the scenes making a quick HTTP call to the service we have running in our infrastructure. And that service just exists to get these little packets of what's going on. I just viewed this particular page. Here's the information of the user's browser, user agent string, all of that kind of information. So that comes in, that service pulls in, listens on HTTP, spits out messages that are in that format to the message queue. Backend messages, that's actually another message queue. Our backend services are publishing to their own message queue. We ingest those, so that ingester in the middle is reading from one RabbitMQ exchange, reformatting the message so that it looks like that blob at the top, and then publishing it to our exchange that's eventually going to get into the warehouse. And then on the bottom, for Postgres, that's a service that periodically runs queries against our backend databases in a controlled manner that is less terrifying than letting end users in the company query the database. It's doing periodic queries, again, taking those rows that it gets, putting them in that format, and publishing individual messages for each row that's involved. So was this a good idea? Kind of. in some ways. There are good things and bad things about what we wrote. As I mentioned, one of the best things about this was we learned making a really well-defined interface in distributed systems is useful and is great. So this idea of let's define this format for what table do you want information to go to, here are the columns and the values, and putting that on a message queue. That's been great. It's allowed us to add extra ingesters on that left-hand side. There are a couple of extra things that I'm not showing here for brevity. So as we've needed to ingest new data sources, it's been really clear. How do we do that? Well, what we need to do is write a new piece of code that ingests from something and then spits out to that message queue in that format. So that was cool. What's not so good about it is, there were 5 different services that you saw on that previous slide. It's been a lot of code to maintain. They've kind of diverged a little bit, and they're doing mostly the same stuff, and it's been not great in terms of maintainability. So we're looking to figure out how can we do that in a more controlled way, kind of have more consistency between how we're building those things, and make it less difficult to deploy. And the other thing that's in there is this has been very focused on the warehouse. It hasn't been focused on streaming. So there are some opportunities going forward of it would be nice to be able to power some real-time stuff with these events. And it would be nice to use some of this information and feed it back into what's going on in our back end and actually affect the product that we're building. And currently it's very focused on getting stuff into the warehouse so that we can do analysis. People can connect via SQL to the warehouse and do stuff with it. Yeah, so we're proud of what we wrote. I'm not going to say this is a great fit for everybody. It was also, it took 4 people, like a year to get this all up and running, which is a huge investment for a lot of organizations. If you are smaller, there are companies that will do a lot of this for you as a service. Even Amazon itself, they now have something called Kinesis Firehose, which I'll just briefly mention. Kinesis Firehose is basically you put things onto Kinesis, which is a different message queue from RabbitMQ, but then it handles everything after that. You just do some configuration. You say, I put this stuff in Kinesis. I want you to put it into this Redshift table, and then it does a bunch of batching into S3 behind the scenes, and it does the loading into Redshift, and you don't have to worry about any of that. So if you were building a system from scratch, use those tools that are available, and don't re-implement all this stuff. But it was necessary at the time. The tools didn't exist, or at least we weren't aware of them. Okay, so what about Python? Jeff, you are giving a talk at PyOhio, and you have not mentioned Python once. In the 30 minutes you have been talking, bad, Jeff. Why have you done this? Well, the dirty truth is that there is no Python in this picture. Why is that? Is it because Python is bad? Is it because Python is not a good thing for this use case? And absolutely not. These services that we have in here, absolutely, they could have been written in Python. But as I was talking about earlier, I feel like context is super important for building an analytics infrastructure. It's somewhat about the context of what is your product, what are you even trying to do, but it's also the context of what's your company and what is the rest of your company doing. So in our case, our Simples backend is largely built in services that are written in Scala. When we started this whole data project, we have really good processes in place for building Scala services and having them be reliable and understanding how to operate them. So for our context, it made a lot of sense to follow that same pattern that our banking backend team was following, which is why these services ended up being written in Scala. I assure you there's no Python in this picture, but that does not mean that we never use Python. And in fact, everybody on my team happens to know quite a bit of Python, and they all love it, and we find a use for it in a lot of glue code. So you'll see a lot of organizations, this is a typical pattern I've seen, where Python is used a lot for stitching things together, for building some tools that aren't necessarily a production thing that you're running, but it's usually a lot easier to build that sort of stuff in Python than in a more structured language like Scala or in Java. So I'm going to talk a little bit about the specifics of some of the tools that we've written. and how we use them. And I'm going to introduce you to a couple of packages. So this is a library that my team wrote called Shift Manager. It's open source. It's available on GitHub, and the documentation's on Read the Docs. What is Shift Manager? It is administrative tools for Redshift. As I mentioned earlier, there are like these tables that you create in Redshift. You have to define this dist key and sort key when you create the table. And Redshift provides no interface for changing those, which kind of makes sense because those affect how data is laid out. So if you were to change the dist key, what does that actually mean? It means that you're rearranging all of your data and telling it to go to different nodes than it's currently on, which is kind of a big deal. So there's no easy way to do that. And if you want to do that yourself, it means you have to create a new table with exactly the same structure, but change the dist key to something else. And then you have to copy all of your data from the one place to the other. And then you have to like delete this old table, and you have to move the other one into place where the other one was. And I feel kind of queasy talking about that operation because it is terrifying. But if you have structure around it and you have a good process and you have code that actually does all that stuff for you, it's a lot less terrifying. So that's the idea of what Shift Manager is doing. It uses SQL Alchemy under the hood. So I want to briefly introduce you to SQL Alchemy if you have not seen it before. It is an amazing library that does so many things. I will tell you about one very small thing that it does. SQL Alchemy is for interacting with SQL databases at a pretty high level. What's going on in this code? We create an engine. Engine is SQL Alchemy's idea of like you tell it about how to connect to a database, and then it pools connections for you. What's going on in this next line is we want to reflect the structure of a table from the database. So we want some object that tells us like what are all the columns in this table, which turns out to be a kind of a difficult thing to do from like SQL queries directly. So you'll see the autoload with parameter at the end of that table statement is calling the engine that we created. So that's actually connecting to the database. It's making some queries behind the scenes and pulling back, this is what this table looks like. And then you can query that object for things like, what are the names of the columns involved. So database reflection, this is really important. And it's also if you want to now change the structure of an existing table and copy the information somewhere else, it's important to be able to know what is the structure of that table in the first place. So we use this in Shift Manager, and then I'm going to give you on the next slide an example of how this gets used inside of Shift Manager. So in Shift Manager, you create this Redshift object. You tell it how to connect to the database. Behind the scenes, it's going to create a SQL Alchemy engine so that you have a way of connecting to the database. And then it provides some nice high-level functions using that connection. So what's going on here is that we call this deep copy function or this method of the Redshift object that we defined. And we tell it, okay, I want to do a deep copy of some table that's called my table. And then we're printing out the result of that. So what this does is it creates the entire SQL batch of statements that you need in order to perform this really scary operation of copying table structure, moving all the data from one place to another, dropping the old table, moving the thing into place. So it does some altering the names of the tables. It creates the new table. You can define a new dist key in the deep copy parameters. And then it spits out exactly what you need to put in a transaction to do that whole operation safely. So this has been incredibly important for us to feel like we can actually make important changes to the database as we understand how people are actually querying stuff to make that more efficient. Okay, one more tool I'm going to talk about that we wrote in Python is that we wrote a service actually running in Python that schedules some of this administrative task stuff. So if you have never heard of Celery, it's a cool Python library that does a ton of stuff that I'm only going to tell you a small piece of today. But we ended up using it basically just to write something that's kind of like cron. It just runs some scheduled tasks and does so in a way that we were actually able to integrate it with our infrastructure that lives in AWS. So Celery, what you do is you define an app. So what you see at the top there is, we create this app that's a Celery object, and then you use decorators to define functions that are registered as tasks for that app. So this vacuuming is an operation that you need to do from time to time in Redshift on your tables. It cleans out old records, and it enforces, you define the sort key. When you vacuum the table, it actually makes sure that everything is in that sort order, and it helps increase the efficiency of queries by doing that regularly. So we do this every night. We vacuum and analyze all of our tables. And we use Celery to do that. So this is an example of registering a task with Celery, and now that's available for you to tell Celery, hey, schedule this task and run it from time to time. You configure Celery with just a Python file. Celery beat is the scheduled task subcomponent of Celery. So this is a little blob of how you define a Celery beat schedule to say, I want to do this vacuuming of my tables every night. And I want to do it at 2 o'clock in the morning UTC time. And then actually running your Celery app is pretty simple. You pip install Celery, it gives you a Celery executable, and you say, hey, Celery, run my app, which is defined in this Python package called Redshift Scheduler, and you give it the beat command to say, hey, actually do this scheduled task thing too. And our actual service code is funny in that it's just that one line of, hey, start Celery, and then it's doing all this Python stuff. So I'm going to wrap this up. Taking a look back at this infrastructure, I'm going to leave some time for questions. As I mentioned, this is a system that works. I think it's a good example of just understanding what are the phases of what you need to do in a data infrastructure, getting it into Redshift. I've not talked at all about how do you actually visualize this information, how do you make it useful. I'm kind of leaving it at the SQL layer of if you give people SQL and people know SQL, then they'll be able to use it. So we do have people that directly query Redshift, but we also provide some tools for dashboards. We use Chartio, if you've ever heard of that. It provides a Tableau-like interface where people in the organization can go ahead and drag and drop things from tables and do joins, and they can see visualizations of queries. Yeah, there's a lot of this stuff that companies have abstracted away from you. I definitely encourage you, especially if you have a smaller team, to look at more kind of pre-baked products to do this stuff. I think I'm going to leave it there, and I would love to take questions that folks have. All right, up in front. Yep.
So you guys were told to use Redshift, and you had to kind of make it work. How did the decision to use Redshift?
Okay, so the question is, how did we decide to use the Redshift as opposed to some other data warehouse product? It seemed like a pretty obvious decision because of the context that we were working in. Like everything that we do is in AWS already, so we're familiar with how do you deploy things in AWS. It would be difficult to transmit data to some other cloud provider. That's a big part of it. Another part of it is in terms of data warehouse products, Redshift is pretty cheap. I haven't done detailed analysis of what it would look like to use some other product for it. But it's a fully hosted thing. There are a couple of times that we've had to enlarge the size of our Redshift cluster, and it's pretty magical. You just say, I want twice the number of nodes, and it goes into read-only mode for a couple of hours, and then it comes out on the other side, and you've got twice as much space to play with. It has not always worked out that way, but ideally it does work out that way. Yeah, so that's basically it. It's a hosted service. It's less stuff for us to manage. We were already in AWS, so it was easier to integrate with, and it's a relatively inexpensive option. Yeah.
So the Amazon marketing literature always describes Redshift as a petabyte scale data warehouse.
Yep.
Is your data set anywhere?
We are currently at 3 terabytes. And so yeah, and I said we're at 32 nodes. We're of the smaller of the node types that they offer. Yeah, so Redshift can go much larger than what we've done.
32?
We have 32 nodes, yeah. Yep, and they have nodes that are 8 times larger than that, and you can do like many hundreds of them. So in the back.
What are you using to manage the schema definitions across your other picks? Are you doing anything explicitly registering that somewhere, or
That is a pain point of the current world. Yeah, we have not really figured out that problem. So the question was schema definitions. How do we manage that? Do we have some schema registry? And the answer is no. And that has caused problems of, in some cases, like when we're reading backend messages, it's kind of our backend engineering team is using that for their own purposes. We're kind of like tapping it into it as this side thing. So they sometimes make changes to those data structures that we aren't aware of. And then it causes difficulty, and we end up having to do backfills, and that can be kind of a painful thing. So that's, if you're going to build out a data infrastructure and you can have some policy or some technical solutions around that starting out, definitely do it, because it can be painful when schemas change and you're not aware of it. Yeah.
So you mentioned one of the deficiencies is the lack of streaming support.
Mm-hmm.
Just wondering why you don't tap another stream off of your routed as you program.
So it is entirely possible, like you could tap into Rabbit. Part of the problem with that is, so Rabbit is this publish-subscribe model where like you have to be already subscribed to it in order to get the messages. So there's some limitation, and and then as soon as all of the consumers have said, yeah, I got the messages, then it deletes them. We're actually, one of the big things that we're changing right now is we're moving to Kafka rather than RabbitMQ. I was getting some thumbs up in the back. Yeah, Kafka is awesome. I would say one of the biggest threats for us making technical decisions is that I am in love with Kafka, and I assume it can do everything, and it basically can do everything. It is like the data store of my dreams. So Kafka is kind of a message queue. You can use it for similar things as RabbitMQ, but it's durable. By default, it keeps messages around for 7 days. You can configure the heck out of that and do really cool things with it. And also, the throughput that you can get from Kafka is great. Also, Kafka is creating, so one of the new things is there's this Kafka Streams library that gives you this really nice way of defining a high-level application that does really complex joins between streams and stuff. And part of it is just it's a scary thing to get into to figure out how are we going to join all this information together. We're building stuff on Kafka Streams right now, which I'm also super excited about. So that's part of the streaming architecture thing, is that Kafka is just a more flexible and better base to start doing some of that streaming stuff on compared to RabbitMQ. Yep.
I'm just wondering, when I say batch, assuming it's not real time, so how do you deal with that? So if I deposit money, when am I going to see it? And how do you use fraud analysis for that? Real time.
Yeah. So in terms of analysis use cases, we found that we were originally doing this batching thing at a 5-minute interval. So as things happened, they were in Redshift within 5 minutes, and that was good enough for pretty much all the analysis use cases we had. That has proven to not be scalable as the number of tables we have has increased. So we've scaled that back to 15 minutes. We may need to scale back to only loading stuff every hour. So that increases the need for having a streaming solution where we can visualize some stuff in more real time.
There's a couple of Python projects that do some of this stuff, Luigi and Airflow being two of them.
Yep.
I'm curious if you looked at those at all, if you were just really kind of focused on Scala.
We definitely would consider, we've been looking at Airflow in particular, and particularly what I was talking about, the Celery stuff I was talking about, we never should have written that. We should have used Airflow in the first place, and I think it would have served the same need. Airflow can do, Airflow is something written in Python. You can register Python jobs with it, and you can schedule them in Airflow. So that is a case where I wish we had used something pre-baked, and Airflow was very new at the time, so it wasn't quite clear what the future of it would be. All right. Thank you. get started. Thank you everybody for coming. I'm Jeff Klukas. I am giving this talk that is called Building an Analytics Platform. Hopefully you read the longer description of the talk. You know that I'm going to talk about data warehouses. I'll define what that is. Specifically, I'll be talking about Redshift as the data warehouse that Simple uses. There's the URL on that. This is based on a blog post at that URL that I wrote last November. And in general, this talk is about experience that Simple had building kind of the first version of our data architecture and how we perform analytics. A lot of this has changed in terms of what we actually do today, but it's kind of a nice snapshot of how did we decide to build what we built and what is the point of it. So what even is analytics? That's a good question. What is an analytics platform? If you have a preconceived notion of what that is and it differs from what I'm presenting on today, I am sorry for that. There are a lot of terms in technology in areas that are quickly changing that who even knows what they mean? In terms of what is my understanding of what analytics is, it's about a business understanding what's going on in the business itself and understanding its product. How are users using that product? How do you gain insight into that so that people can make reasonable decisions based on having some idea of what's actually going on in the real world? So an analytics platform is about gathering that information about what's going on with the business, what's going on with the product, and putting it in a place where people can actually analyze it and make decisions based on it. At the bottom of the slide, I have this blurb about meeting Simple. I think it's really important, because analytics is so much about allowing the business to improve. It's about understanding what is the business doing. You kind of have to have some context for what even is this this business that we're building a platform for. So I want to give you some of that context. I'm going to spend kind of the first 5 minutes of this talk introducing you to Simple, both as a company and as a product. As I was rehearsing this, I realized that those 5 minutes kind of end up sounding like an advertisement for Simple. And I'm kind of okay with that because I think it's a cool product. I definitely encourage you to go to simple.com and sign up for an account. I'll tell you more about what Simple is in a little bit. First, I want to tell you about the company. So this is Simple's headquarters. When I started, we're like, okay, we're supposed to build a data platform. And we kind of learned from the ground up how to do that. We're going to kind of follow that. It took us about 6 months to put together our first draft of it, and then it took us another 6 months to kind of build out all the data sources that we actually wanted to get into that platform. I'm going to talk more about Simple's product in just a moment. If you don't already know about Simple's product, you may know Simple for another reason, and I'm about to troll the Columbus residents in the audience. Are there any soccer fans in here? Okay, well, this troll is not going to work very well. Simple builds a product. They're also a sponsor of the Portland Timbers. So if you're not familiar with soccer, Portland, the Timbers played the Columbus Crew in the championship that we just moved into this past summer. It is in Portland, Oregon. I do not live in Portland, Oregon. I live in the Columbus area, and I work remotely. When I joined Simple, it was about 150 people total, and for our engineering workforce, about a third of us are remote. So the team I work on particularly, we've kind of fluctuated. Some people have moved to Portland, some people have moved out of Portland in the time that I've been there, and it's been about half remote. I work out of the guest bedroom in my house, and I get to eat lunch with my 2 kids and my wife every day. And I have found my happiness. It is a wonderful situation. So yeah, I love working remotely, and I love being a part of Simple. So what I'm going to talk about today, there was a team of about 4 data engineers